Hello everyone, I hope you are doing well. So in this video, we are going to discuss Geeks problem of the day, and today's problem is max sum without adjacent, and it is an easy level problem. And although it is an easy level problem, the idea for this particular problem actually comes from a dynamic programming approach. So I would say that this problem can be solved with DP, but I'll also tell you one thing at the end with which you can solve this problem without even knowing DP. Right. So we'll discuss the DP solution first, and then we'll have a look at what we can do. So first of all, that it says that we have been given an array of n integers. So all of the integers are positive, and we have to find the maximum sum of any possible subsequence such that no two numbers in the subsequence should be adjacent in ARR or the array. Right. So basically, let us consider this case only. We have the values 5, and then we have 5, 10, 100, and 10 and 5. So we want to select a subsequence from this particular array, and we want to select it in such a way such that no two adjacent elements are taken. So for example, if I have taken this particular 100, I cannot take this 10 and this 10 as well, right? So I am allowed to take this particular 5 and this particular 5, and you can clearly see that this is the maximum sum only. So 100 plus 5 plus 5, so this is equals to 110, right? This is the maximum sum that we can get in this particular case. So it means this is the whole problem. If we take any particular element for the sum, we cannot take the whole, like the adjacent elements, right? So how can we actually solve this problem with DP? Let us first understand that. So I'm going to have a DP of these dimensions. So this will be n, right? So I'm going to have a double dimensional DP of dp of n2. So let me just write it clearly what dp of the dp sets will represent, right? So let's say dp of ij is going to represent something, and let's say when j is equal to 0, right? So when j is equal to 0, dp of i0 is going to represent, let me just make this bigger, is going to represent the maximum sum from starting from index I, provided the last element was not taken, right? Now let's consider a case when j is equals to 1. So dp of I1 is going to represent the max sum starting from index I, provided the last element was taken, right? So these are the two cases that I have. That means dp of I0 will be basically storing the maximum sum possible starting from the value or the index I, right? And considering that the last element was not taken, similarly dp of I1 is going to represent the maximum sum starting from index I, considering the last element was taken. So why do we have to deal with these two situations separately? Let's say we have this particular situation here. So let's say this 10 element was not taken, right? If this 10 is not taken, I can definitely try to take this particular 100, right? But what if this particular 10 has already been taken? That means I cannot take this particular element again, right? So it clearly depends that if I have taken the previous element, so this is the previous element, if I have already taken it, I cannot take my current element, right? So we are going to use this whole idea to form the DP. Now let's say my base case is dp of n. So dp of n0 will be equals to dp of n1, and both of them will be equals to 0, right? Why 0? Because when we have exhausted the array, when we have reached the position n, means we have completed all the elements of the array which were from the index 0 to n minus 1, right? If we have completed all the elements, that means our maximum sum can be 0 only, because we cannot take any elements, right? So this will be our base case. Now how do we actually solve this particular problem? With the help of recursion. So let's say I have my recursive function. So I'm going to have my helper function, let's say, which is going to receive two variables, int I and int j, right? So these represent the I and j that I have discussed just now, right? So let's say I'll have this thing here. Now if I is equals to n, I can just return 0 from here. I will return 0, and let's say if dp of ij is not equals to -1, I am going to return dp of ij. Otherwise, I am going to form the two conditions, right? So let's say I am trying to form the answer for dp of I0, right? So let's say dp of ij, or instead what you can do is, instead of getting the j here, you can write both of the cases together. So dp of I0 will be what? dp of I0 means that I have not taken the previous element, right? So I can try to take the current element. Let's say the current element is array of I plus dp of I plus 1, 1, right? So this is the case when I take the current element. The previous element was not taken is signified by this particular 0, right? So what happens if I take the current element? The sum will increase by I, and I have to move on to the next element, right? And I'll also have to indicate that the previous element was taken, right? So I'm going to set my answer as helper of I plus 1, 1, right? So let's say int j, I'll have to receive it because I need to calculate the answer for this particular case, right? Now the other case can be when I don't take the current element, so that will be helper of I plus 1 and 0, 0 because I have not taken the previous element for the index I plus 1, right? That means I have not taken the element at the ith index. Now what I can do is I can set my dp of I1 as dp of, or maybe helper of I plus 1 and 0. So why this thing? If there is a 1 at the current position, that clearly means that I had taken the previous element and I cannot take the current element. So I will directly move on to I plus 1 index. Now if I don't take the current element, this value will be 0, right? So at the end I can just return dp of ij. So I have calculated actually both of them, right? So I have calculated both of them, but I can just try to return dp of ij, right? Or even better, if you don't want to do all of this, you can just write it here. If j is equal to 0, then execute this particular condition. So in that particular case, I am going to execute this particular condition. In the else part, I can have this, right? Else I can execute this particular condition, right? So I can even have it like j here and j here as well, right? So you see that only one of them will be executed. So this is how you can clearly solve this problem with the help of a recursive function. So what I have done is I have created a helper function. I have checked the condition if I is equal to n, I'm just going to return 0. Otherwise, if dp of ij is not equal to -1, I can return dp of ij. If j is equal to 0, I'm going to execute this particular part. Otherwise, I'm going to execute this particular part, and in the end, I can just return dp of ij. Right. So this would be my whole solution. Now, how to do it iteratively? I'll show you directly in my code. So you see, this is my simple code for this particular problem. Now again, similar to a lot of problems, I see that I have to calculate I plus 1 before I. Why? Because my answer of dp of I depends on dp of I plus 1. That means I plus 1 will have to be calculated before calculating I. Right. So this is exactly what I have done. I am taking the for loop in reverse order because I need the answer of I plus 1 when I calculate dp of I. Right. So as you can clearly see that this is exactly the same that what I have done in the recursive function. I use the same relations or the same transformation, right? You see dp of ij when j is equal to 0 will be the max of these two values, and that is exactly what I have done here. dp of I0 is maximum of these two values. Now dp of I1 will be equal to this particular value, and at the end you can return dp of 0, 0. Why dp of 0, 0? Because 0 will be the starting index, and I want the answer starting from the first index, and 0 means that its previous element was not taken. That means I can take the element at the 0th index, right? So if I just submit this and show you that this particular code works, so you see it passes all the test cases. Now again, a simpler next approach would be like, let's say you don't want to use dp, so I will have two variables. So let's say I'll have two variables, next a and next b. So let me write it as next 0, next 1. Right. So next 0 is equals to next 1 is equal to 0, right? So now what happens? what I'm essentially trying to do is, I'm trying to form the same answers representing by dp of I plus 1 0 and dp of I plus 1 1 by representing these two variables. So int, let's say current 0 is equals to maximum of area of I plus में next 1 comma next 0, right? Int current underscore 1 will be equals to next 0, right? Now I can remove this and I can update my current and next. So my next 0 will be equals to current 0 and my next 1 will be equals to current 1, and my answer will be next 0. So if I just first try to compile this, let us just first run and then I'll explain what I've done. So it is compiling correctly, and let me just quickly submit this code. So you see, we have just space optimized the earlier solution. Now you might find this solution at many places, this particular solution, and you might think that what is happening here you might not understand at the first instance. So that is why I explained to you the DP approach first. So you see, here you have not used the term DP, here we have just calculated all the things directly, but the idea is the same, right? So I only use two variables to find the whole answer. I have space optimized from O of n to O of 1, but the idea behind using these two variables will be essentially the same that we use in DP. It is much easier to understand the idea using DP. That is why I explained it that way, and then you can just space optimize it your code to this particular code, right? So this is how you can solve this particular problem. It is nothing, it's just that I have represented dp of I as current 0 and 1 and dp of I plus 1 as next 0 and 1, right? So the rest of the things are exactly the same, and when I am done with the current scenario, I'll just update the next 0 and next 1 for the next iteration, right? So this is how you can solve this particular problem. I hope that you guys were able to understand the solution. If you guys said that, consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video was actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.